Hello everyone, and welcome to our new unit. This unit we're going to be talking about the solar system. Now this is actually going to be our last unit where we have to take notes. So, yay, we're almost done with the school year. Alrighty, so the solar system. Your title is the solar system. The essential question is, what objects are found in our solar system? As usual, Cornell notes, you should have title and essential question at the top of the page, 2 columns. Smaller one is for questions, key points, important vocabulary, things like that. And your bigger column is for your notes. At the end, you do need a summary. So let's get started. First of all, to refresh your memory, we talked a little bit about this in our first set of notes on space, way back at the beginning of March. So a solar system is a star with planets and other objects orbiting around it. So first of all, what we need to talk about is how distance is measured in the solar system. Now, in space in general, we use light years. And we use those because there's just so much distance between objects in space, we have to use something that big. Now, in the solar system, things are still pretty far apart, but they're close enough together that using light years doesn't quite work, because light years are just too big. So in the solar system, distances are measured in what we call astronomical units, or AUs. What an AU is the distance from the Sun to the Earth, which is 150 million kilometers. Now, the solar system actually extends over 100,000 AU from the Sun. So the solar system is still very big, still a lot of distance between objects, but if we were to use light years, we'd have to use a lot of decimals in there. So astronomical units are easier for us to use to measure distance in our own solar system. So what's in the solar system? Well, we of course have the star in the center, which is the Sun. But going around that, we have planets. And going around planets, we have moons. Now, planets are objects that are rounded by their own gravity, so they have enough mass to have enough gravity to make themselves round. They also orbit the Sun. They've cleared out their region of orbit, so that means that within their orbit, there is nothing else there, unless it's orbiting around that planet like a moon. So there's nothing else in its path. Now, our solar system has 8 planets. We also have a few dwarf planets, which we'll talk about a little bit later. Now, moons are any object that orbits another object that has a greater mass than it. Most of our planets have moons. The Earth only has one. When you get to the larger gas giants like Jupiter and Saturn, you have more moons. So bigger planets tend to have more moons. So, dwarf planets. The most famous dwarf planet would be Pluto. And Pluto is the most famous because Pluto was once considered a planet. Now, a dwarf planet, very, very similar to a regular planet. It orbits the Sun, has enough mass to have been rounded by its own gravity, but it has not cleared its orbit. So that means there's still stuff in its general area. So it's not all by itself with just a couple of moons orbiting around it. There's other stuff there in its general area. Now, most of these orbit in a region that we call the Kuiper Belt, which we'll talk about a little bit later. There are currently, to our knowledge, 5 dwarf planets in our solar system, and this includes Pluto. There might be more out there that we haven't discovered yet. We're always making new discoveries about space, so there very well could be more dwarf planets out there. But for now, we only know of 5. Dwarf planets can also have moons. And let's go ahead on to the next slide. Now that's not all that's out there. There's also smaller objects. And those smaller objects are classified by things like their size, their shape, what their orbits are, what they're made up of. And we'll talk about those individual things in just a moment. Now, most of these small objects are found in 3 areas. We have the asteroid belt, and the asteroid belt is between Mars and Jupiter, and it's a large region where there's a lot of asteroids. Now, another region, as I mentioned before, is the Kuiper belt. Now, this is actually past Neptune's orbit. So this goes to around 50 AU from the Sun, so it is pretty far away. And again, that's beyond the orbit of Neptune. And then, past the Kuiper belt, we have what we call the Oort cloud. And that, scientists aren't entirely sure exactly how far it goes. We can't exactly tell. But scientists believe that it extends somewhere from 50,000 to 200,000 AU from the Sun. So this is a huge cloud around the Sun, around the whole solar system, actually. So what sort of objects do we find in these areas? Well, we have comets. And comets are loose collections of ice and dust and rock. They orbit the Sun in very long, narrow ellipses, so a very long, narrow oval. And most of these originate in the Oort cloud. So they come from the Oort cloud. We also have asteroids. Asteroids are small rocky objects that have an irregular shape. Most of them are actually less than 1 kilometer in diameter. So most of them are pretty small, but there are ones that are much larger. For example, in the bottom picture, in the corner, you can see that there are ones that are much bigger. Now, most of these orbit in the asteroid belt. There's a few oddballs that don't, but most of them are in the asteroid belt, and that's exactly why we call it the asteroid belt. And we also have meteoroids. Meteoroids are chunks of rock or dust. They are smaller than asteroids, usually less than 10 meters across. And just to give you an idea of how big that is, our classroom is a little bit more than 10 meters from front to back. So we could probably fit an asteroid, your average meteoroid, we could fit the average one in this classroom probably. These sometimes form when asteroids collide or comets break up, so they could be formed from pieces that are broken off of those. Now, meteoroids often get confused with meteors and meteorites. Meteors are when a meteoroid enters Earth's atmosphere. So if a meteoroid comes close to Earth and it enters our atmosphere, now it's a meteor. Now, it becomes a meteorite when it not only passes through Earth's atmosphere, but reaches Earth's surface. So while it's still out in space, it's a meteoroid. When it's in Earth's atmosphere, it's a meteor. Once it hits Earth's surface, it's a meteorite. So that's the difference between those 3. They're all the same thing, it just is a matter of where that thing happens to be at that time. And that's it. So of course you do need to do your summary. Just like with the last unit, your notes are going to be all collected at the end of the unit, and it will be worth a lab grade. So make sure that you do get it done, hang on to it, don't lose it. If you do lose it, you're going to have to redo the notes, which we all know you don't want to do. So don't lose them. All right, guys.